Hello, my name is Shraddha, and today I'm going to be discussing a very interesting probability problem. There really is no high funda math involved, so it's almost bad to call it a probability problem, but if there's any topic in math that it's associated to, it really is probability. It's more of a brain teaser though. So, let's get started. So Bob lives midtown, Manhattan, wherever, midtown of his town. And he's in college. And every day after college, he goes to the train station to visit either his mom or his girlfriend. His mom lives uptown, his girlfriend lives downtown. Now, Bob leaves his college at random times. I mean, he has, some days he hangs out with friends, some days he stays, studies late, leaves whenever he wants to, so he doesn't have a fixed schedule. There's no fixed weekly schedule, nothing. And his principle of fairness makes him decide that when he reaches the train station, whichever train he finds first, he'll take that one. In other words, if he finds a train going uptown, he'll take that one to visit his mom. And if he finds a train going downtown come first, he'll take that one and visit his girlfriend. So he thinks, he's being totally fair. And so it would seem, and things carry on like this for a few months. Finally, after 6 months, his mother complains to him that he's been visiting his girlfriend far more often than he's been visiting her. In fact, she does a calculation. She's good at simple math, and she sees that it's 90% of the time he visits his girlfriend downtown. And so she thinks that even though he told her of his strategy, and even though he thought he was being totally fair, and she agrees that that strategy would be totally fair, she thinks something is going wrong, and that he's really seeing his girlfriend more often. So the question is, if Bob was really being honest and really stuck to this strategy, does his mom really have reason to suspect that he is lying and that he's actually, quietly visiting his girlfriend more often? Or could it just be that, is there a reason why these trains would be taking him downtown more often? Now let me give you some other information about the problem. There are an equal number of trains that go uptown and downtown during the day, right? And they're equally spaced. In other words, they're like 10-minute, half-an-hour gaps between them, whatever you want. There's a n-minute gap between the trains. There's an equal number going up and down, and they're equally spaced, so it's not like during the mornings most of the trains go uptown, and during the night when he's free, most of the trains go downtown. Also, Bob leaves at, random times. And so can you come up with an explanation? Now's a good time to pause the video and think about it. Alright, so I've asked only a few people this problem, maybe 4 or 5, and nobody managed to come up with a solution. It's not a mathematically hard problem, doesn't require great visualization or great mental abilities, but it's tricky because it's a little counterintuitive. So once again, let me reiterate some conditions of the problem and answer some questions that you may have. Bob leaves at random times. So it's not like Bob is reaching the train station, usually closer to the 10th minute of the hour than the 12th minute of the hour. It's just completely random. So you can imagine the probability of him reaching during any minute of that hour is 1 by 60. If he was to reach in an hour. It's just completely uniformly random. He has no fixed schedule at all. He just leaves his college and reaches the train station whenever he gets the mood to, he suddenly feels like. The trains have a fixed schedule. In other words, the trains don't come randomly. They come at regular intervals. And there are equal number of trains going uptown and downtown. So it's not like them, and it's not like the trains going uptown go uptown during a certain part of the day, and those going downtown go downtown during a certain part of the day. It's continuous. So the equal number of trains, the equal intervals between the trains, and Yeah, so what else could be the reason? I remember one really intelligent person I had this discussion with. She was really smart, and finally she said, there was a inner connection for his girlfriend that made the trains come downtown, take him downtown more often. 90%. He loved his girlfriend. If he gave 90% of his heart to his girlfriend and 10% of his heart to his mom and the universe obliged. But more seriously, is there any other explanation for this? Now's a good time to pause and think, scratch your head a little bit. So, the way one can really arrive at the solution, if you haven't already, is by actually writing down a sample train schedule. So let's say the trains come every 10 minutes. Actually, let's say the trains come every half an hour to keep things simple. So this is the train station. This is Bob's college. Bob gets out of college, comes to the train station at a random time. Train A goes uptown. Train B goes downtown. And we know that the trains are regularly spaced. So I never give you any information on what the exact schedule was. So is it possible to come up with a schedule that would, make the trains downtown, make him catch the trains going downtown much more frequently than he would catch the train going uptown? What if, think about it for a while, pause the video. So what if trains A, right? The train A going uptown came at times 9:01, 9:31, 10:01, 10:31, and so on every half hour, while the trains, this is the trains B going downtown, while the trains A going uptown came at times 9, 9:30, 10, 10:30, and so on, again every half hour. Now the only way that Bob would catch the train going uptown is if he came in that interval between 9 and 9:01. Any other time, and he'd catch between 9 and 9:31 if he reached the station. He'd catch B, which is going downtown. The only way he could catch A is if he came between 9 and 9:01, between 9:30 and 9:31, 10 and 10:01, 10:30 and 10:31, and so on. So it's really, even though they as frequently going up and down in the equal gaps between the train's arrivals, and they're going throughout the day, this relative timing is very important, which is, it's a simple idea, but it's a little hard to catch. And in this case, if the gap was 10 minutes, if it was 9, 9:01, 9:10, 9:11, then the probability of him going downtown would be 90% and uptown would be 10%, because that's out of those 10 minutes, 1 minute would be the interval to catch his mom. Here the probability of him going uptown would be even less. It would be much, 3 times. It would be, we can calculate it out, but the probability is basically 1 in 30 rather than 1 in 10 of him going downtown. Which is like 3%, so there would be like a 97% chance of us going uptown. So a simple problem, but very hard to catch for some reason. Thank you.